All right, so we are gonna do the next one. Okay. So we are gonna start with the problem decomposition, as always. Maybe I'll put this here, and then, cut this down. Maybe not. N people standing in line, labeled 1 to N. Okay? First person holds pillow initially. Every second person passes pillow to next person. Okay. Once it reaches end of line, direction changes. Okay. So given two positive integers, n and time, find index of person holding pillow after time seconds. Okay. So let's go through a few examples because I believe this can be done iteratively. I mean, not iteratively. Analytically, whatever, like through an equation of some sort. So let's switch to this scene here. And I think there's basically a few different examples, or a few different cases or situations. So we have n, which is number of people, and then we have time. Okay, number of seconds. Okay, so let's say n equals 4, t equals 5. So what that means is I have 1, 2, 3, 4 different people, okay? So this 1, 2, 3, 4. Let's say there's this many people. I have a few cases, okay? So what is my first case? My first case is t is less than n. If t is less than n, then we're just going to be then it's basically going to be counting this way by n. Okay? If t is equal to n, let's say t is equal to 4. So t is less than n, let's say t is equal to 2. If t is equal to 2, then what would the answer be? T is equal to 2, so that means that it's less than, t is less than n. In this case, I have it here, which is the output should be 3 because it starts at 1, goes to 3. So if t is less than n, then the index is going to be 1 plus t. Because in this case here, where n is 3 and t is 2, the output is 3. Okay, so what happens if t is equal to n? So if n equals 4 and t equals 4, let's see here. Let's do t is equal to n minus 1. So if t is equal to 3, then I go from 1, so 1, 2, 3. So it's going to be, in this case, if that's going to be index is equal to 1 plus 3 equals 4, which works. Okay, so let's say t is equal to n. T is equal to n. In this case, n equals 4, t equals 4. That's the first time where we get a reversal. So here we go 1, 2, 3, 4. And it's 3. So what would the formula be? So if t is in between n and maybe it's 2n, I don't know, I think so. T is equal to n, what's the time? Fine. So I believe this is it. So let's try. So let's say t is equal to 4. So 1, 2, 3, 4. Yeah? So it's, what if it's 1, 2, 3, 4, 5, 6? One, two, three, 4, 5, 6. Okay, so let's rethink about the problem. So, let's say it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so let's say, so n in this case is 5. So let's go from t, okay? 0 is going to be 1. 1 is going to be 2. 2 is going to be 3. 3 is going to be 4. 4 is equal to 5. So 1, 2, 3, sorry, if it's 4. 1, 2, 3, 4. I'm going to be returning the 5th index. Or actually, yeah, okay, so it's going to be the 5th person. So this is the person number, and this is t. Okay, so if I get to 4, so this 4 is n minus 1 here. So if I get to 5, I'm going to be reversing. So it goes 1, 2, 3, 4, 5. So that's going to be here. So 5, 6, 7, 8, 9, 10. So 6 is going to be 3, 2, 1. So this right here is n minus 1 times 2. Okay? So, and then it repeats, right? So 9, it goes 2. So what is the pattern here? So there's 3 different situations that we can be in. I hope I'm getting this. Fine. There's 3 different situations that I can be in. I can be from t is between 0 and n minus 1. In that case, I count from beginning. Okay. The next situation is t is from n to what? 2 times n minus 1. Because this is n right here, right? 5 and 5. So if it's from there to basically 2 times 8, I'm going to be doing what? What is the situation? It's going to be kind of in reverse order. So reverse order, I believe. It's going to be what? It's going to be 5. So it's going to be, the number is going to be equal to t plus 1 here. It's going to be traveled 1, 2, 3, 4. So it's going to be is equal to n. No, it's equal to t minus 3, 4 n. That's going to be, in this case, where t is 5 and n is 5. 1, 2, 3, 4, 5. T minus n. T minus n. 1, 2, 3, 4, 5. What is this? 8. So it's going to be t, which is 5, minus n minus 1. N is 5, 4, so t minus n minus 1. I believe that's it, because that's 5, right? And this is 5 minus 1 is 4. And then it's that from end. So I think it's going to be n minus t minus n minus 1. Let's check it out. So n is 5 minus t is what? What is t? T is 5 minus 4. 5 minus 1 equals 4. That's it, okay? So it's n minus t, and that's t minus n plus 1. So it's equal to n minus t plus n minus t plus n minus 1. So it's 2n minus t minus 1. Is that it? So let's see. N equals 5, t equals 5. I get 2n, which is 10 minus 5 minus 1, which is 4. That works. And then in this case, where it's above 2n minus 1, I can just do mod 2n minus 1, I believe. So in this case, it's 9. 2n minus 1, that's 5, 4, 8. Okay? So 9 mod 8 is 1. That's the same as here. Okay, so here are the 3 cases. That was kind of annoying. So let remaining, or let functional without repeat. So it's going to be t mod 2 times n minus 1 so if without repeat is greater than 0, I guess greater than or equal to 0, and without repeat is less than or equal to n minus 1, return t plus 1, and then return 2 times n minus t minus 1.